My name is Lauren Perla. I am in the Department of Mechanical Engineering, and I'm working with the NASA Idaho Space Grant Consortium with a group of 8 people, and we are studying gravity waves. This summer, we are being trained to travel down to South America to measure the total solar eclipse. What we're doing here in Moscow is we launch weather balloons weekly. We attach a radiosonde to the end of the weather balloon, and it tracks different data like temperature, humidity, wind speed, wind direction. With the data we require from the radiosonde, we can put them into different programs, and we can make graphs and other different models. Also, the data we acquire can go to the National Weather Service. The first thing we have to do during a launch is prepare our ground station, where we'll be communicating with the radiosonde as it goes up in the air. Next, we have to put up our weather station, which is going to tell us what is the pressure and other atmospheric data right now on the ground level. We take that, we put it into our programs, and we initialize the radiosonde. Once the sonde is being initialized, we start to fill the balloon. We fill it up with helium, and it takes about 10 minutes. Once the balloon's done being filled, we duct tape it and zip tie the end, and we attach the radiosonde to the bottom with its parachute, and we let it go in the air. It takes about 2 hours to rise at a 5 meters per second, and once it pops, it takes about 30 minutes to fall. All this practice is going to help us when we go down to South America, because we will be launching balloons every hour on the hour through the whole solar eclipse. So we want our processes to be down just perfect. The reason why we acquire this data is because we're trying to make our weather prediction models better. We cannot predict weather 100%, but with this data, we can get closer to being there. The better we understand gravity waves, the better we can predict for severe weather in the future.